Section 8.2 non-right triangles, law of cosines. In this section, you will use the law of cosines to solve non-right triangles, solve applied problems using the law of cosines, and use Heron's formula to find the area of a triangle. Law of cosines, we can use the following formulas interchangeably anytime we have an oblique SAS side angle side triangle with sides and opposite angles as labeled in the figure to the right. So let's say this is our angle A, opposite is the side A, this is angle B, opposite of it is your side B, and this is angle C, opposite is side C. And these are the formulas. A squared is equal to B squared plus C squared minus 2BC cosine of A. And the other one, B squared is equal to A squared plus C squared minus 2AC cosine of angle B. And the third one, C squared is equal to A squared plus B squared minus 2AB cosine of angle C. So take a look at all these three formulas. So angle opposites of, let's say this is, this is angle A, this is angle B, and this is angle C. Let's try some examples. Example 1, find the unknown sides and angles of the triangle below. So we have side A here. So definitely this is your angle A, this is angle B with a side B, and angle C with a side C. So let's start with solving for the side B. So we know the formula is B squared is equal to the other two sides, A squared plus C squared minus 2AC cosine of the angle, which is angle B. So B squared is equal to A is 10 squared plus C is 12, so 12 squared minus 2 times 10 times 12 cosine of angle B, 30 degrees. So B squared is 100 plus 144. 2 times 10 times 12 is 240 cosine of 30 degrees. And to solve for B, we want to get the square root of both sides, so that B is equal to 6.013. Okay, next. Now, how about we have now two missing angles, A and C. So let's start with A. So if we use the formula, A squared is equal to B squared plus C squared minus 2BC cosine of angle A. And we have side A is equal to 10, so that's 10 squared. B is 6.013 squared plus C is 12 squared minus 2 times 6.013 times 12 cosine of angle A. So this is 100 is equal to 6.013 is 36.154 plus 144 minus 2 times 6.013 times 12 is 144.5 312 cosine of angle A. And then we subtract both sides, 36.154 and 144. And you will get 100 minus 36.154 minus 144 is negative 80.154 is equal to negative 144.312 cosine of angle A, and then divide both sides by negative 144.312. So that's going to be 0.5554 is equal to cosine of angle A, and then to solve for angle A, that is inverse cosine both sides. And it is equal to 56.26 degrees. And to solve for angle C, so we know that, again, A plus B plus C is equal to 180. So angle C is 180 minus A, 56.26 minus 30, so that it is equal to 93.74 degrees. So we now solve all the unknown sides and angles. Next, example number 2. Find the angle for the triangle with sides A equals 20, B equals 25, and C is equal to 18. So given all the three sides and one angle, given the three sides, find angle A. Let's say we have this triangle here, angles A, B, and C. And this is side A, which is equal to 20, and this is side B is equal to 25, and C is equal to 18. So we want the opposite. So solving for angle A, so that's A squared is equal to B squared plus C squared minus 2 BC cosine of angle A. So A is 20 squared is equal to B 25 squared plus C squared 18 squared minus 2 times 25 times 18 cosine of angle A. 20 squared is 400. 25 squared is 625, 18 squared is 324, 2 times 25 is 50, times 18 is 900, cosine of A. So 400, 625 plus 324 is 949, minus 900 cosine of A. Then do not subtract these two, so you have to subtract both sides. 949, so that you have here negative 549 is equal to negative 900 cosine of A. Divide both sides by negative 900. So negative 549 over 900 is 0.61. And then next is inverse. Use this space here. Inverse cosine, not sine, sorry, of 0.61 is equal to angle A. So that A is equal to 52.41 degrees. Okay. Next, example number 3. Cell phones use GPS to approximate the location using the process called triangulation. Suppose there are two cell towers with a range within the range of a cell phone. The two towers are located 6,000 feet apart along a straight highway. So, like these are the two towers 6,000 feet away, running east to west, and the cell phone is north on the highway. Based on the signal delay, it can be determined the signal is 5,050 feet from the first tower. So this is 5,050 feet and 2,420 feet from the second tower, which is this side. Determine how far the cell phone is from the first tower and how far it is from the highway. So two things here. First, we can solve for the angle theta here, and that is by using the law of cosines. Since you have the three sides given, and then after that you can use SOHCAHTOA to find the height h. So let's start with the first one. Use the law of cosines to find this angle. Angle theta, opposite of that is 2,420. So we use 2,420 squared is equal to the other two sides, 5,050 squared plus 6,000 squared minus 2 times the two side, 5,050, 6,000 cosine of theta. So we want to isolate the theta. So first we subtract 50 squared and 6,000 squared, both sides. These are big numbers. So 24,020 squared minus 5,050 squared minus 6,000 squared is actually equal to negative 55,646,100 is equal to, if we subtract 2 times 5,050 and 6,000, that is 60,600,000 cosine of theta, and then divide both sides by 60,600,000. And this is negative, and that is equal to 0.91825. It's equal to cosine theta, and then inverse cosine both sides. to isolate theta, which is our, let's say, use your calculator and you will get 23.33 degrees. Then to solve for the height, so we have now this triangle here. This is what we want to solve, the height, and we already solved for the theta here, which is 23.33 degrees, and we know this hypotenuse is 5050 feet. So we can solve and use sine of 23.33 is equal to, opposite side is the height over the hypotenuse 5050. Then we cross multiply this with 5050 times sine of 23.33 degrees is equal to the height, and then use your calculator. You will get 1999.93 feet. Okay, next, example number 4. A boat leaves port, travels 10 miles due north, and turns 20 degrees west, and travels another 8 miles. Now the question is, how far is the boat from the port? Okay, so from the port it travels 10 miles due north. So let's say this is the port, and this is 10 miles. Then turns 20 degrees west and travels another 8 miles. So let's say this is 8 miles, 20 degrees, so meaning this is 20 degrees, and we want to get how far is the boat from the port. So this is the boat, how far it is from the port. So if this is 20 degrees, so we can say that this angle is 180 minus 20 is 160 degrees. So we want how far is the boat from the port, so this. So we can use law of cosines. Let's say that is your c, so c squared is equal to a squared plus b squared minus 2ab cosine of angle c. So c squared is equal to the other two sides. So let's say if this is a, this is b. So 10 squared plus 8 squared minus 2 times 10 times 8 cosine of opposite is angle 160 degrees. So c squared, 10 squared is 100 plus 64 is 164 minus 2 times 10 times 8 is 160 cosine of 160 degrees. And remember to isolate c, square root both sides, so that you will get c is equal to 17.73 miles. Okay, next, Heron's formula. Our last formula for area of a triangle comes from the Herons of Alexandria, who discovered it in the 1st century AD. This formula is useful when we know the sides of an oblique triangle but no angles. And here's the Heron's formula. square root of s times s minus a times s minus b times s minus c, where s is equal to a plus b plus c over 2. That is 1/2 of the perimeter of the triangle, and sometimes we call it a semi-perimeter. Okay, let's use that formula to answer example number 5. Find the area of the triangle below. So as you can see here, given all the three sides, A is 10, B is 15, C is 7. And we want to find the area. So here first, you have to solve for S. So A plus B plus C over 2, add all the sides, 10 plus 15 plus 7 divided by 2, which is equal to 32 over 2 is equal to 16. And then use the area formula. So that is square root of S, which is 16, times S minus A, so 16 minus 10 times 16 minus 15 times 16 minus 7. Again, we're using this formula. Sixteen minus 10 is 6, 16 minus 15 is 1, 16 minus 7 is 9, and 16 times 6 times 9 is 864, so that the area is equal to 29.39 square units. Okay, example number 6 next. A Chicago city developer wants to construct a building on a triangular lot drawn below. How many square meters are available to the developer? So we have here the sides. So this side here is 43.5, this side here is 62.4, and this side here is this side, which is 34.1 meters. And again, take a look at the question, how many square meters? So meaning we want to find the area. And remember, before we use the Heron's formula for the area, we need to solve first for S, which is equal to 43.5 plus 62.4 plus 34.1 divided by 2, which is actually equal to 70. And then next is find the area. So that is S times 70 minus 43.5 times 70 minus 62.4 times 70 minus 34.1. Simplify, use your calculator, and you'll find the area is equal to 711.42 square meters. Okay, next let's work on our lecture questions. And the first problem, 113-foot tower is located on a hill that is inclined 34 degrees, so this angle here, to the horizontal as shown below. A guide wire is to be attached to the top of the tower and anchored at a point 98 feet uphill from the base of the tower. And then find the length of the y needed. So to solve this, we are using this triangle here. We have the two sides 113 feet and this is 98 feet, and we can get this angle here. So just think about this. If this is a right angle, so meaning this is 34 degrees, so this is 34 degrees, and since this is a right angle, so that is 50 plus 34 is equal to 90, so we can say that 56, sorry, this is 56 to make it 90-degree angle. Then we can use the triangle. We're going to rewrite the triangle here with 56 degrees here. This is 113 feet and this is 98 feet. So let's say this is angles A, B, and C, and we can solve for this. So we can use law of cosines, that is c squared is equal to a squared plus b squared minus 2ab cosine of angle C. So c squared is equal to a 113 squared plus b 98 squared minus 2 times 113 times 98 cosine of 56 degrees. And I'll let you use a calculator and you will get 99.9 feet. Okay, use your calculator for that. Okay, and the last problem. Number 2. The graph below represents two boats departing at the same time from the same dock, located at the origin. This is the origin. The first boat is traveling 18 miles per hour. So this is 18 miles per hour at heading of 327 degrees, and the second boat is traveling at 4 miles per hour at a heading of 60 degrees. Find the distance between the two boats after 2 hours. So again, the first boat is traveling 18 miles per hour at a heading of 327 degrees. So from the origin to here, that is 327 degrees. And the second boat is traveling at 4 miles per hour at heading of 60 degrees. So this is 60 degrees. So if this is 327, this is 360, so meaning 360 minus 27, this is 33 degrees. So we want to find the distance of the two boats after 2 hours. So we can say that after 2 hours, this is going to be 8, because this is 4 miles per hour, so after 2 hours it's going to be 8. Then here is, instead of 18, that's going to be 16, and we want this. Let's say this is our C. So this angle C, and this angle C is 60 plus 33 degrees is going to be 93 degrees. Okay, so let's say this is our A and this is our B. Now we can use law of cosines. to solve for c. So c squared is equal to a squared plus b squared minus 2ab cosine of angle c. So c squared, 8 squared plus 16 squared minus 2 times 8 times 16 cosine of 93 degrees. C squared is equal to 64 plus 16 squared, 256, minus 2 times 8 times 16 is 256 cosine of 93 degrees. So this is 320 minus 256 cosine of 93 degrees, and then square root both sides. And you'll get C is equal to 37.3 miles. Okay, and that's it for section 8.2, and this is actually our last lecture for this semester. If you have any questions, let me know. Thank you.